Ladies and gentlemen, this is Mr. Green. I am recording this session, study number 1 in AP Statistics, so that you can watch it at any time. We will be discussing these things in the class Connect, but I just want to make certain I give you all the information I can right up front. Okay, so what we're looking at is actually the 4th unit in TXBA's uh, uh, lesson, but it's going to be our unit 1 because it just is better to do the sampling information right up front so that it makes sense, because we'll be using those words and a lot of the vocabulary that's talked about in this lesson, and I just want to make certain we get that covered. Now, what I've pulled up here is a version of your course. And now it went so big you can't see it. I'll try it again, making it do that. Okay, this is your course, and you can see here that it's got lots of terms that you need to be looking at. I'm just looking at the topic 4.1 experimental designs, and if you click right here, it's going to show you all these terms that you need to be able to learn. Okay, there's not going to be much math, much calculation that you're going to have to do. It's just a lot of terms that you've got to define. Now, I'll be nice to you. All these things are all there. It gives you the definition right there. So you don't have to go a real far away to find the definition of these terms, but you do need to understand what these terms are. Okay? So what I'm going to be doing is this study number 1. This study 1 here is some vocabulary about data collection. Okay? And I've got to get it to open here. It didn't have it open already. Okay? And what it's got in here are some terms that you need to have defined. I'm going to try to define some of them, and I'm going to go over some of these different things that you'll need to understand, and I'm going to try to do it pretty quickly here. But since you can record this as recorded, you will be able to go back and watch this as many times as you want to. Okay? So don't panic. I know it's going kind of fast. Oh, one other thing. Yes, this is a TI-83 calculator. Yes, you will be using a TI-83 calculator in class. Make certain you know how to get one, get your hands on one. There's one in the document sharing if you need to get to one, and it just is a little bit of help there. Okay? We'll be using that later on, not today though. Okay? So, how do we go about gathering data? Well, one way is to take a survey of some people. One way is to interview people. Some people think about it, studies where they study some different information. They got observational data or retrospective data that might have happened in the past, or prospective data, things that might happen in the future. Those are studies that might be done. And the last one here is experiments. We're going to be looking at all of these over a period of time, but for right now, we're just going to talk about how do we get the sampling. Okay? Now, one of the things you got to understand is that there's a population. Population is everybody, every possible person that fits into whatever you're looking at. Okay? So if you're looking at TXVA students, well, there's about 3,000 of them. Kind of interesting. If you're talking about Texas residents, wow, big number. If you're talking about the people that live in your city, could even still be a big number. Okay? So population is everybody. And there's a problem with that. When we try to count everybody in a population, it's called a census. And censuses are not a good representation. Now, what I'm going to ask you to do is to pause your video. In document sharing, you're going to find a thing about the frog fairy tale. It asks you to count some information, okay? And when you go through and count it, you will be able to get a number, okay? Do that. Stop your video right now. Go count them, okay? And see what you get. Waiting just a second, making certain you all have finished doing that. When you've restarted your video, you're back here with me, okay? In that froggy fairy tale, what was the count? The answer I got was 83. 83 is the correct answer. Now, your number might have been different from 83. That's pointing out to you some information about a census. Censuses are not always accurate. One of the problems with censuses is they're very expensive to do. If you tried to count everyone in the state of Texas, it's kind of expensive to do it. That's why the U.S. government only takes a census once every 10 years. It might actually be impossible to do. If you were asked to count all the frogs in a particular pond, you actually don't know if you ever got all the frogs. There might have been one hiding there. Okay? It's very difficult to count all the frogs or all the fish in a pond or anything like that. It's difficult to do. Might even be impossible to do. And what if you were doing a sampling that caused you to have to destroy the sample in the process? Okay? For example, you wanted to know how much the breaking strength of a soda bottle is. Well, you break it, it's broken. You can't go back and put it back together, okay? The lifetime of a flashlight battery. You turn it on and leave it on to measure how long it lasts, and guess what? It's dead. You can't turn it back, can't relive it again, okay? Safety ratings for cars. Well, the way they do that is they crash the car. Guess what? The car is destroyed. Those things are things that if you're doing a census trying to do all of them, it would be impractical. Okay? So what do we do? Well, we can't take censuses every time. So one of the things they do is they make a sample. A sample is a part of the population. It's not the whole population. It's just a part of the population. Okay? And we're going to look at that sample and we're going to make a determination of what we want to know. And we're going to use that sample to generalize the entire population. We're going to say this sample basically is the same as the entire population. Okay? And whatever we decide about the sample is what's going to be true about the entire population. Is that always true? There's some things that say it is, some people that say it isn't, but it gets you really close to it a lot of times. And we'll talk about that in other lessons that we go through. Okay? Now, when we talk about taking a sample, we have to have a method that we use, and they call that method the sampling design. This refers to the method we use to choose the sample from the entire population. Okay? One of the things that we talk about doing is taking a random sample. Random meaning there's not an organized method to it. Okay? We're going to be using a lot of random number generators and random number tables and things like that. And I'll show you how that works in a future lesson. But for right now, what you just need to know is that it refers to the method that we're going to use. Okay? So, the frame is simply a list of every individual that we're going to use in the population. And we're going to go from that frame to come up with a list of what we're going to use for our sample. Now, a couple of terms that also show up in this lesson are, one of them is incidental data. This is not really data at all, but it's an opinion or an accepted truth. Okay? Like what, Charles? Okay, well this is an example here. And it's talking about people using their intuition or their personal experiences as data. It might not be bad data, but there's no way to track improvements because no measurements were ever established. You might say students were terrible at grammar, and you try some intervention as a teacher, but then 2 terms later you cannot tell if the intervention was successful because grammar problems still exist, but you don't know if the problem exists to a lesser extent or not. This is one of the reasons why Texas developed the state testing that they did. Because they kept saying, well, our students are doing worse in school, and our students are doing worse in school. We had no data in which to base that information on. So they came up with the state testing so that they could start determining, are the students doing better or are they doing worse than they did before? Not an individual, but the overall state of the data. Okay? This is where the state was coming from when they first came up with the thought of doing some state testing. Okay? Now, available data, this is just data that's there. You might not have collected it. You might not have done anything to get the data at all. It's just there, or it's easy to obtain data. Okay? Now, a lot of people confuse these two, incidental and available. Okay? That's why they're paired together here in this topic, is because they just seem to fit together very well. Okay? People confuse things that they know from data that just happens to be out there. Okay? For example, I'm sure you've all heard that 4 out of 5 dentists, that's a commercial that's been on TV for years and years and years. Do you know it, or do you have data to support it? That happens to be an incidental data, incidental information. Why? because you don't really have any data to support 4 out of 5 dentists doing that. You've just been given that information and you believe it and you go from there. Okay? One of the things we want to talk about is observational studies. This is when you see a human condition and the way things that changes that occur. It's also data that was collected by someone else, but you can use it for your purposes. Note, in either case, it's stagnant, not something that you can see the effect of you doing anything on. Okay, so it's just looking at the human condition and the changes that might have occurred in that human condition. Okay. An experiment is something that you see an effect of doing a particular condition. For example, I've got a new and improved dog food. I'm going to start feeding it to my dog. My dog has brighter and shinier coat. That's if I set that up with a sample size and come up with data, that's an experiment that I could do to see that my dog's coat is brighter and shinier based upon the new dog food that we're giving it. Does that make sense? Now, if it's just me alone doing it to my dog, that would be incidental data. I know it's true. It's not something that we did an experiment on. If we created an experiment and got a random sample of dogs, fed them the new dog food, some of them not the new dog food, and compared their coats bright and shininess afterwards, we might have data that we collected through an experiment that would be a valid bit of information. Okay. Now, in our Class Connect that we have on Thursdays, I will start going over some of these. This is a discussion example that we'll have. It says one school board member noticed that students in a band tended to be the top 25% of their school, and it goes on. I want you to read this discussion, and we'll have some questions that we'll talk about afterwards, okay? Here's another discussion. It says another school board member was surprised the increase was so slight. A little bit more information, so they're going to do something else, and we'll discuss that. Okay, this is a third example. It talks about Walmart is considering buying a gasoline additive. We'll talk about those 3 discussions are things that I want you to make certain you understand before you go into, or that you have seen before we go into the discussion. So you'll look at those and we'll talk about them during the Class Connect. Okay, now when you're taking information and when you're gathering data, one of the things that you might notice is that in an observational study, you think there's X and Y, but there's some other variable. It's called a lurking variable sitting out here that's affecting both X and Y, and you just didn't know it existed. But it does affect what you're seeing and your observations that you're seeing. Okay? For example, if you were measuring fuel mileage in that last one, there might be, in that last thing, I don't want to give away any answers here, but there might be something else that's a lurking variable that's affecting both the fuel additive and the non-fuel additive people that you didn't know existed. For example, traveling during a rainstorm might affect it, whether it's more effective. And you might have some people that are traveling in a rainstorm and others that aren't. Okay? In an experiment, there might be a confounding variable that might be confounding something that's affecting one and not affecting the other. What could that be? Well, you might have some people that drive with a heavy foot. That might affect some of the drivers, and other people who are much more cautious drivers. That would affect gas mileage, but it's not something that you got into your experiment. It's called a confounding variable. Okay? Well, I just wanted to make certain you understood those 2 things. The last thing I'm going to talk about here is called randomized comparative experiments. Our goal of an experiment is to collect statistically significant evidence for a cause and effect relationship. Here's the cause, here's the effect. Okay? If we don't take into account all the variables, we don't get a good cause and effect relationship. So understanding what is causing things to happen is why we put together experiments. Now, I'm going to be making videos like this so that you can watch them over and over again so that you can get the information. I know I go fast, but I want to make certain that you're getting all the information and you get a chance to watch it as many times as you need to. Okay? I will talk to you later.